Today we look at another type of surface known as quadric surfaces. After this discussion, you must be able to sketch quadric surfaces, be it manually or using technology. So what are quadric surfaces? Now, a quadric surface is a graph in space of a second-degree equation in x, y, and z. And the most commonly now encountered quadric surfaces are the following. We have the ellipsoid, the elliptic paraboloid, the elliptic cone, the hyperboloid of one sheet, the hyperboloid of two sheets, and the hyperbolic paraboloid. Showing you next are the quadric surfaces with the corresponding equation describing it. Here is the ellipsoid. This is how it looks like. And that the equation describing it is of the form x squared divided by a squared plus y squared divided by b squared plus z squared divided by c squared is equal to 1, where a, b, and c are arbitrary constants. Here is the paraboloid. This is called the elliptical paraboloid, and it is described by the equation x squared divided by a squared plus z squared divided by b squared is equal to z divided by c. So it is squared in just two variables but linear on the third. This is how an elliptical cone would look like, and the equation describing it is of the form x squared divided by a squared plus y squared divided by b squared is equal to z squared divided by c squared, where a, b, and c again are arbitrary constants. A hyperboloid of one sheet would look like this one here. The equation is of the form x squared divided by a squared plus y squared divided by b squared minus z squared divided by c squared is equal to 1. A hyperboloid of two sheets has this shape. The equation is given by z squared divided by c squared minus x squared divided by a squared minus y squared divided by b squared is equal to 1. And we have the hyperbolic paraboloid, okay, which look like a horse saddle. The equation is given by y squared over b squared minus x squared divided by a squared is equal to z divided by c, where c is greater than 0. So how do we sketch quadric surfaces manually? Now let us work with a particular example, sketching the quadric surface defined by the equation 36x squared plus 9y squared plus 4z squared equal to 36. And if you're given an equation of this form, what you have to do is to transform this to the standard form, the form of the equation where the right-hand side constant is equal to 1. To do that, we need to divide both sides of the equation by 36, transforming this equation to the form x squared divided by 1 plus y squared divided by 4 plus z squared divided by 9 is equal to 1. Now, using this form of the equation, recognizing that this conforms with the form of the equation x squared divided by a squared plus y squared divided by b squared plus z squared divided by c squared equal to 1, which is the standard form of the equation for an ellipsoid with center at the origin. Then to sketch the ellipsoid, now we do the following. We first locate where the intercepts are. These are the intersection of the surface with the coordinate axis, the x-axis, y-axis, z-axis, done by equating any two of these three equations to 0. So if we set y and z to 0, we will be able to locate the x-intercept of the ellipsoid, and that would just be equal to plus or minus 1, obtained by solving the equation x squared is equal to 1. Locating now the y-intercept, we set x and z to 0, so the equation reduces to the form y squared divided by 4 is equal to 1, and that would return value of y equal to plus or minus 2. For the z-intercept, we set x and y 0, and work with the equation z squared divided by 9 is equal to 1 to give us z values of x of plus or minus 3. So we have now determined the intercept. The next thing to do is to determine what the traces of the quadric or this particular quadric surface is. Now, the traces of the quadric surface will simply be the intersection of the surface with the coordinate planes, meaning the intersection with the xy plane, the xz plane, as well as the yz plane. Now, how do we investigate for the traces? If we will be investigating what the xy trace is, or the intersection of the surface with the xy plane, then we set z to 0. So in this equation, if z is 0, we simply come up with an x squared over 1 plus y squared over 4 is equal to 1. Okay, now we recognize this equation here to be an equation of an ellipse on the xy plane with major axis along y, minor axis along x. Now, as to what the xz trace is, we now look at what the intersection of the surface is with the xz plane, and we can do that by setting y equal to 0. Hence, we come up with equation x squared divided by 1 plus z squared divided by 9 is equal to 1, again representing an ellipse but now on the xz plane with major axis along z and minor axis along the x-axis. Okay, now for the yz trace or the intersection of the surface with the yz plane, we set x equal to 0. The equation now is reduced to the form y squared divided by 4 plus z squared divided by 9 is equal to 1. Another equation representing an ellipse, but this time on the yz plane with major axis along z and minor axis along y. Okay, so we consolidate the result of our analysis. What we do is we plot the intercepts. So the x-intercepts are at plus or minus 1. So we have this point. This is at 1, 0, 0. And here is negative 1, 0, 0. And then plotting the y-intercepts at plus or minus 2. We have the point 0, 2, 0 and 0, negative 2, 0. And the z-intercepts are at plus or minus 3. So we have this point here. This is 0, 0, 3. And the other one is at 0, 0, negative 3. Now, the next one is now to plot the traces. So, if you start with sketching what the xy trace is, the xy trace is given by the equation x squared divided by 1 plus y squared divided by 4 is equal to 1. As we said, this would just represent an ellipse, but it is an ellipse on the xy plane. So we plot the ellipse. The major axis will be along the y-axis, minor along x. Semi-major axis is of length 2 and semi-minor axis is of length 1. So for this ellipse, the ends of the major axis will be at 0 to 0 and 0, negative to 0, where the ends of the minor axis would be at 1, 0, 0 and negative 1, 0, 0. So with these 4 points, you will be able to draw this ellipse. Okay, now next, if you will draw the yz trace of the ellipse with the equation y squared over 4 plus z squared over 9 equal to 1, the major axis of this ellipse, which is on the yz plane, would be along z, minor axis along y, and the major axis would end at the points 0, 0, 3 and 0, 0, negative 3, where the minor axis would end at points 0, 2, 0 and 0, negative 2, 0. Again, with these vertices, you will be able to draw this ellipse here. Now, this ellipse is fronting you. It is an ellipse on the plane of your monitor. Okay, now for the xz trace, we work with x squared over 1 plus z squared over 9 equal to 1. Again, representing an ellipse, major axis along z, minor axis along x, and that the major axis will have endpoints at 0, 0, 3 and 0, 0, negative 3, where the minor axis would end at 1, 0, 0 and negative 1, 0, 0. So if you connect those 4 points in a smooth curve, you end up with this ellipse here. So imagine that these are wires. Okay, so what you do is you cover this skeleton with a piece of cloth, and the covering would be the quadric surface, now which we called an ellipsoid. Okay, so if we are going to summarize what was given in this particular discussion, a quadric function involving all three variables x, y, z would represent what we call a quadric surface, and the most commonly encountered quadric surfaces are the paraboloid, the ellipsoid, the hyperboloid, and the cone. And that if you are to draw or to sketch the quadric surface, then you may work with the following data. You can locate the intercepts, the intersection of the surface with the coordinate axis, and then investigate what the intersection of the surface with the coordinate plane would be. These are what we call the traces. Now, this data or this information will greatly help you in sketching the surface defined.